So good evening. Thank you very, very much for coming. It is a pleasure to host you here in London for the 2017 Colo Club. From what I've heard, there's only about 15% of you who were here last year. Who was here last year? Could you raise your hand? Thanks for coming back. So you're new for this. We're going to have a very exciting full agenda tomorrow. Tonight we're going to try to keep it light. I will, at my peril, I will let you know that the bar is going to be open throughout our session tonight. So depending on how you feel here, and how late we keep it, do what you have to do. So I'm Dave Johnson. I'm the Executive Vice President of the IT Division for Schneider. And if I translate that, that is the former APC part of Schneider. So Schneider bought APC 10 years ago. Our division takes care of all the activity in the data center for Schneider. We directly produce things like UPS systems, cooling systems, rack enclosures, rack PDUs. We do data center software services. Other parts of Schneider create switchgear, BMS systems, power monitoring systems, and other components that go into the data center. My division does not manufacture those, but it's our job to pull that all together in reference architectures, reference designs, and have you have a sort of a seamless experience from us as you take on the whole Schneider story. So tonight I'm going to just touch on a few messages that our CEO typically talks about what Schneider's sort of all about right now. It's mostly pictures. This format here is a little challenging with our screen, so there's a couple slides you won't be able to see too well, and we'll just chat amongst ourselves here, and we'll work around it. Okay. So I'm just going to do a quick intro, and then I'll introduce kind of our main speaker tonight, who's an old friend and customer, and we'll get to him as soon as we can here. So Schneider's now, very, like many companies, we very much focused on digital. So how many were at Data Center Dynamics today? A lot. Good. Okay. So you hear a couple of messages. Certainly, everybody's going. Every industry, everybody's going digital. We talked a lot about the edge today. That's a huge focus for me personally and for our team in watching that evolve and figuring out what our role will be here. But Schneider, very serious about being sort of the power behind the digital economy, tackling the energy side of the digital economy that's coming. At a high level for Schneider, we kind of see this as our challenge. So the world is, there's substantial growth in the demand for energy. So in the next few decades, the demand for energy overall will grow about 50%, about 1.5 times what we have today. Meanwhile, for the planet to be healthy, at the same time as all this demand is there, we've got to cut CO2 to make the planet a livable place. And the way that you round out that equation is through energy efficiency. So part of the story in taking care of the planet from an energy standpoint is renewables, but we believe far more of the equation is around optimizing, making things more efficient. This is kind of a high-level view of the company mission overall. The trends that we see, so as that energy demand is increasing, more of that will be electricity or electric versus other forms of energy. So we're perfectly happy to participate in that more digital world. We've heard lots of statistics about connected things, anywhere from 25 to 50 billion connected devices in the next few years, getting to that level. I heard my colleague, Mike Hughes, in one session today, he made some interesting comments about that's probably extremely conservative. If you think about how digital our lives are becoming, the idea that there's just sort of a handful of connected devices per person doesn't feel quite right, that it's probably going to be much more than that. So maybe this is a low number, but this is the world we're living in. A more a decarbonized world, and there's a number here, 82%. The 82% is the opportunity that's left in efficiency in buildings. Okay? And if you look at industrial applications, about 50%, but if we're trying to make this hotel, our office buildings that we work in, more efficient, there's still about 80% of the opportunity left to go out there and capture. So tons of opportunity left. It's something that Schneider's very, very much focused on. And finally, more decentralized. So from an energy standpoint, we go from centralized production of energy to microgrids and decentralized production of energy and energy storage and everything that kind of comes with that, with renewables. So that's kind of the world that we see and the important trends for the world, I think, as well as for Schneider. The grid and power generation being transformed by a few factors: digital, the declining cost of lithium ion, and also of renewable energy. This is really going to drive a lot of change, and this is something that that certainly we have our eye on. And this is the part where you can't read, so you'll have to trust me here. But this creates a lot of opportunities for us in a lot of applications. If you look at the declining cost of renewables, the digitization, the rise of energy storage, you get opportunities in energy storage specifically in the business. You get renewable energy, microgrids, and lots of opportunities for us in the data center space as well. Continuing with the slides that you can't read, especially from the back. So one thing, and I'm going to try to pause on this for a minute. How many have heard Schneider's story around EcoStruxure? Maybe you did today if you were here. Okay, thanks for my friends up front. But so I think this is something you're going to hear from. You're going to hear us talk about EcoStruxure over and over again. So I kind of want to go through this quickly, even though it's hard to see on the slide. But EcoStruxure is Schneider's architecture to support the Internet of Things era, the Internet of Things in general. And this is across everything we do. So whether it's in a factory environment, in the grid, or in the data center, we are organizing our products, our software, our analytics capabilities around this thing called EcoStruxure, our IoT-enabled architecture. So specifically for the if we go through some of the components, the main layer of EcoStruxure at the bottom, the starting layer, is connected products. So it is imperative throughout the company that all our products are connectable and then ultimately connected, so we can monitor them and make sure we understand the health and manage them properly. And then the next middle layer, which is depicted by this middle green bar here, is edge control, or things, so tools that we use at the edge to monitor all these connected products. At the top is apps and analytics. We have some of these products now. We continue to build more of tools that help us monitor and get insights. We can do preventative maintenance, things like that, and do other things at in the sort of the analytics category to optimize everything we're doing. Now we have a version. We have versions of this for each of the applications that we're in, and certainly including the data center side. So it's the connected products, it's edge control, and it's apps and analytics. And this is something you're going to hear us talk about till you cry, possibly. But this is something you're going to hear a lot of. So we do this across a lot of domains. So at the bottom here are some examples of our connected products. This is from across the company. This is not in data centers necessarily. But you'll see applications in power control, building control, IT, machine control, plant control, grid control. These are some of the domains we're in, and then the top just simply depicts some of the apps that we have or are developing in all these spaces to support all that. This is meant to be very much an open ecosystem. We recognize Schneider. Even in the data center, we don't expect you to have all Schneider environments. We want them, maybe 80% is okay. But we know you have mixed environments, so this is meant to be very much be an open architecture to support what you have, everything you have in the data center, at the very least in the physical layer that we operate in. We intend to be, we are experts there already. We intend to keep increasing our expertise and help you in that space. So it's an open architecture, and the same. So some of the partners are listed up here. Partners like Microsoft and Cisco and Accenture. We're working with industry consortiums. We're also working with lots of startups. So this is kind of unusual for a company like us. So we recognize there are a lot of agile companies that can add to our capabilities. We want them part of our story, so we're integrating this into our ecosystem. So the EcoStruxure was actually introduced about 10 years ago in Schneider. And it was originally, so Schneider's a complex company, and at about that time, we were a holding company of different sort of silos. And we decided to kind of rally behind one brand and start to collaborate and operate with one face to the customer. This is a journey that we're still on. We're still a complex company with business units and geographies and countries, and we're still on this journey a bit, but I think we've come a long way. The story has changed a bit, so we've reintroduced this term EcoStruxure. It's kind of faded a bit, but the original concept was this was a architecture around web services, and we were joining all the different things we do from a web services architecture. It's kind of been reinvented for a deeper integration story here, and this is something we've been relaunching or talking a lot about now. But if you look at the if we look at the systems that have some level of integrated products, those connected products, and edge control, and tools installed at the apps and analytics layers, we have these kinds of numbers to brag about. So this is not a brand new thing that nobody's doing. We have customers that are using very integrated solutions from the software layer to the hardware, to the hardware, and out across even competing products. We have thousands of these systems installed across a lot of domains. And the stats that I won't go read all the numbers on the bottom, but we talk about the different vertical industries that we're in, and we're working with many or most of the top companies with these kinds of solutions across the industries that we deal with. And one example from the data center, so this is not a co-location example, but a animation studio in Australia, Animal Logic, and so this is what EcoStruxure might look like for the data center in their case. In their case, they're using prefabricated modular solutions for the data center because they have really cool office space and they don't want to sort of waste it with ugly, ugly data center space. So they have their prefab outside. They're using in-row cooling and other products, but those are examples of connected products. They are using what was our DSIM, which is now our data center infrastructure management software. That's now becoming a cloud-based offer called IT Expert, and they're using our app, an analytics tool called IT Advisor at the top layer. And that's an example of how EcoStruxure comes together in an application like the data center. So that's so the two things I guess I wanted to touch upon were kind of our view of what's going on in the world from an energy standpoint and Schneider's role there. And I want to make sure you get a taste of EcoStruxure. If that was unclear or not terribly helpful, my friend Mark Bittinger is going to talk tomorrow in more detail about this, probably with a set of slides you can actually see when you're when it's morning out. Okay, so thanks for listening to my little intro here. I do want to bring up our guest speaker tonight. My next guest is a longtime customer of Schneider Electric. For the last 25 years, he has really made a name for himself in the industry. He's pioneered some key things in the data center world around optimizing power efficiency. He was actually a pioneer in modular, and Schneider's a big proponent of modular approaches and certainly modular data centers. He is a founding member of the Uptime Institute for EMEA. He's very active in the Green Grid, in the European Commission, and ASHRAE. He's a published author also. And he studied mechanical engineering and later management and economics in business in Rotterdam. He is probably the data center customer that I've known personally the longest, and I consider him my absolute friend. And my pleasure to welcome CTO of Interxion, Lex Coors. Lex.
Well, thank you. So actually it shows my age, being that long. So today we'll go through all of the data centers from Interxion. We'll go into the detail of the designs. We'll talk about the economics now. I'd like to talk about the issue we have ahead of us and what we are doing about this. So it's only 4 years ago that we welcomed the 7 billionth Earthling And think about this, you know, they say, okay, fine, yes, sure. But in 2 years, they will be connected. You remember when well, you don't remember. When I was connected with my mobile phone, it was in the late 80s, and I had a mobile phone about this size, you know, half hour, and I was way in the 30s already. Now they're 6 years old, and they get connected. That's something, you know, to think about. And that's a massive amount of data. And we'll all be searching, we'll all do all kinds of things, games and stuff, and it goes somewhere, it goes to a data center eventually. So, if you look at the power load, the growth, and you look at 2007, 18 gigawatts global load, it was, let's say, from DCD, they did an investigation, I will come up to that. And so we estimate for 2020, 60 gigawatts. I think it will even exceed the 60 gigawatts, but let us be conservative here. Let's take the 60 gigawatts for a moment. What does it mean? Well, it means a lot. Because Jonathan Koomey did a study in 2008, and he said it's about 17 gigawatts in 2005. So what's the impact? I looked at it and I used the EPA carbon emission tool. Anyone who used it before? And the number that came out was something like 102 billion metric tons of carbon dioxide equivalent. Well, I can tell you, in 2005, it was real carbon. What was there about sustainable energy in 2005? We were all running on coal, gas. Oh, we had some nuclear, which was clean, you know, but that was it. So if you think about it, if we put that to 2020 and we say it is 60 gigawatts, then we are hitting it 3 times more. So now we have to do something about it, because that's a serious thing. Because this could be our situation. If you do not change direction, you will end up where you're heading. Lao Tse said it many hundreds of years ago. And it means you have to change the direction. Otherwise, we will be in a situation where we will not see the sun for weeks. Certain countries on this globe, certain cities on this globe, they have this issue. You know, and they're dealing with it. They're heavily investing. I know in China they're investing billions of euros or of dollars to get this solved. And if we don't change direction, we will also heading there. Fortunately, we are heading the right direction. Because we will not decrease our capacities, we will increase our capacities. We're in a very fortunate business. Sustainable energy is the way out. And I believe in, let's say, storage on the front side, not on the back side. I believe that if you want to do something with a sustainable energy source, get away from the grid, get away from the diesel engines, you have to have something up front. So there is a guy, Dr. Sadoway, I met him a few times. I always call him the crazy professor from MIT. And he came up with an idea of liquid metal with molten magnesium and molten antimony. And actually he also showed me that in the old days, or even in the US, they called it aluminum. Now aluminium. Now they call it aluminum, they called it aluminium. So that has changed, but he is thinking that he can do it. He's founded by the Bill Gates Foundation. He has already some models working. And I think that if you want to store 100 or let's say 20 megawatts or 30 megawatts of energy, you can't do it with lithium ion, you know. That's my feeling. You have to have something cheap and useful. So, because how does this new technology impact the resilience? I have fuel cells, I have solar, I have all kind of stuff. Because if I would have a fault-tolerant data center, 2N, all the way down, in solar, built in New Mexico, where the sun always shines, and I have 600 hours of energy storage. I didn't say batteries, I just said energy storage. Then why would that fall below the lowest tier classification. So I'll come to that. So we have to start designing beyond the existing standards. If you think we're here, I can tell you we're about here. You think you recognize yourself? Did you not, Piet? Yes, sir? Here you are. There's a lot to do, a lot to gain, and it's a massive work. Because what we're looking at, today you have the Uptime Institute, BICSI, and the TIA 942, and they have done an incredible good work. They have put a standard together that everyone understands. Uptime calls it Tier 1 to Tier 4. BICSI gives another indication. TIA gives it the same indication. But basically it all comes down to basic non-redundant, basic redundant, concurrent maintainable, and fault tolerant. The issue is, it's all based on diesel generators and UPSs. That's an issue. Because when I talk to the EU, when I talk to, let's say, other governments around the globe in my role as the chair for the Governmental Engagement Committee for the Green Grid, they all say, when will you be more sustainable? I said, well, you know, I have some sustainable stuff there. Yeah, they said, but you still have the diesel generators on the other side. I said, yeah. I said, because otherwise, if I have this fault-tolerant data center on solar, it falls below the lowest tier because it doesn't have the diesel generators. So we came up with another idea, and actually it's the open standard for data center availability, OSDA. And it's to embrace sustainability, it's to embrace innovation, and I call it an open standard because standards per definition in the data center world are obsolete before they are actually done with. 5 years development of a standard in the data center world, come on guys, you know, we changed the whole world in 2 years, so why 5 years or 4 years? So this is an open standard, we don't care. If it changes, if it improves, we follow it. So quickly, we have a lot of experience in Monte Carlo simulations at our company. And so what we did, we run a few of these designs. So this is, you could see as a single data center, basic non-redundant. And you can't see it here, but I can tell you what is there. On the REST server one, it gives you 3 nines. So any failure on the grid or any failure on the system or somewhere in the power line will have an impact. If you do that 2 times and you combine them together with an application in between, so now you have 2 data centers, and let's talk, for instance, say a search engine. So they have the application in between the 2 data centers, and guess what? What's coming out is 5 nines. If you look at the fuel cell system, and this one says it has a bus coupler, so it has a bus coupler here, you have fuel cells here, you have a grid here, it comes to 6 nines. So what does it mean? So what we came up with, and I will quickly go through it because it takes too long. We created a tool, and you can select here on the front end, you can select, for instance, grid and diesel generator, standard way, or you can say, I have solar or I have wind, and then you can see here, well, you can't see, anyone can see here, by the way, a buffer, storage. So it says, if I have solar and I have storage, then I have a number coming out of here, same here. So here you make a choice, primary selection for grid or diesel or here, or solar or wind. Then you go to this one, this is your backbone on the electrical system. Then you go here to your cooling system. Every time you make the same decision. Is it basic redundant, basic non-redundant, concurrent maintainable, or fault tolerant? Very solid words that we all understand in the industry, thanks to BICSI, TIA, and Uptime Institute. And you go all the way through. Then at the end, there is a number coming out. It's a bit sad that you cannot read it here, so it's a little bit more here. It doesn't matter, guys. It's unreadable. So this is something you can, if you do not know how it looks like, you can, or have a drawing, then you can click on the drawings as well. And we go through it. So at the end, a number comes out, and in this case it says 1.98 OSDA score. It means nothing to any one of you, nor to me. When I saw the number, I said, that's great, it doesn't mean anything to me. So then the second choice is if I connect it to the cloud or let's say to a second data center, then the number goes up because now I have 2 data centers with a shared application in between, and the number goes to 7. Still means nothing. What am I looking at? So what is the idea? We created an overview. So here you have basic non-redundant, basic redundant, concurrent maintainable, fault tolerant, and anything beyond. And now you can see if I would chose a basic redundant wind turbine with energy storage and a grid backup, and I would do that all the way through in a kind of, let's say, concurrent maintainable way or in a basic non-redundant way, the number that comes out is 2.9. So now I understand, hey, it's better than basic non-redundant, it's little less than basic redundant. What do I want? Will I now get some money out of the design and go back to basic non-redundant? Because it falls back to the lower tier. As we all know from the Uptime Institute, it never goes halfway the up, it always falls back to the lowest. So here's the same, so you can say, okay, I have a title with grid backup, 2 NUPSs, it scores 6.2. Okay, 6 is concurrent maintainable, there's a range obviously here, it's not a fixed number. So now you can make business decisions. The interesting thing is, this is for consultants, engineering bureaus, the Schneiders of this world, where they can actually reach out to senior management and sit at the build of the business case. If you think that engineers make the decisions for the designs, you're wrong, guys. Because if I ask my engineers, design me a data center, they will give me a 10,000 square meter data center with space for 1 rack, and I can even put it in the Mariana Trock, you know, 10 kilometers deep, it will never fail. So, unusable. So the guys who understand what you have to do with the data center, they make the decisions. And the engineers, the people in my department, we simply work it out. So now, these guys, you have the opportunity to say, if you want this, if you want to be, let's say, sustainable, and you don't want to use, let's say, the diesel generators, or you want to use something else, then this is where you get. Make your decision. Go back, go forward. Eventually, this will also come with an IT part. It will also come, let's say, I want to have the pricing tool in it. So that doesn't say have to be so many euros per kilowatt or so many euros, but just say this is a base and then this is plus, this is minus 10%, 20%. So people understand the impact of design and the impact of their selection. So kind of, that was it for the moment. But the question is this the end? Because 60 gigawatts, 2020. You know, 7 years ago, we started talking about cloud. 5 years ago, IoT. When I talked to the Japanese government a few years ago, they actually said, Lex, you know, IoT, that's implementation, easy. It's a lot of work and a lot of stuff we will be doing, but it's implementation. He said, we're working on artificial intelligence. And I said, you mean machine learning? No. Machine learning is algorithms. Artificial intelligence is algorithms with emotions, intuitions, and feelings. I said, you're building Skynet. He said, well, he said, in a way we are. I said, but then you will have a union for artificial intelligence. He said, we haven't thought about that one. So, but that's where we're going. And then look at this one, these two, virtual reality, augmented reality. What's the impact? I can tell you, 40 billion in 2020 in revenues. That's the expectation. So if you look at today, we have 90 flops, the virtual reality goggles. Nice. Look where they're going, 144. Everything here, 0 incremental latency, full immersion, body full tracking, everything. So I will be standing here in a few years. You will be all sitting here. I can feel the audience, I can talk to the audience. We'll not be here. We will have dinner together, and Amazon may drop, let's say, my dinner with a drone somewhere. And you can still smell my food because I have the sensors on my body. You may smell my body, but okay, let's take to the food for the moment. It got complicated here, guys. So, no, but in all, you know, to be serious, many things will change. If you put on a goggle like this, you will have a constant feeling of déjà vu. The zero latency difference, so it's massive. This is where we're going. Imagine the amount of data, imagine the amount of data centers and storage you need for this. And with that, I will not keep you in between the beers and the fun, so actually, that was it. Thank you very much. Thank you.